Hi everybody, my name's Shawn. I'll be leading you through the next couple of weeks in an indoor and outdoor experiential learning exercise concerning succession, biodiversity, food webs, population dynamics, the math involved with those, as well as vegetation, predator, and prey dynamics. Right now I'm standing in a field at the top of San Joaquin Park here in Oakland, California. This area of the park burned about 150 years ago due to a lightning strike, and large portions of the area haven't recovered since, mostly due to human intervention. We'll be exploring areas of the park through this video right now, and then in a couple of weeks we'll come out here and visit. You'll be collecting data out here by yourselves. Follow me to the next area. Here we are at our second location. This is only about 50 yards away from where I first spoke with you. I'm standing in front of a stand of eucalyptus trees. These are considered invasive, they're non-native. They were imported in shipping containers back during the gold rush. They're highly subject to fire, and they're also allelopathic, a term I want you to be familiar with before the end of this term. Allelopathy means other plants aren't easily able to grow underneath of these plants due to a chemical that they excrete. And if you look down below here close up, you can see a lot of weeds. Canadian thistle, for instance, which is part of the reason why I want you to wear long pants when we come out here to explore. We're going to head off to the next area and we'll be discussing more forest dynamics. Here at our third location, we're standing in front of what's considered a stable ecological niche with two native California varieties of evergreens. The one closest to me that's slightly smaller is the California oak, and the big tall guy in the middle, that's the California pine, our Monterey pine. If you'll notice the understory below these trees, there are other types of vegetation growing underneath that are adapted to growing in the shade. That's an additional term that I'd like for you to understand. Understory, the mid-story, and the canopy. Let's head off to our fourth location. Check out this little guy. This is a small example of the coast redwood, or Sequoia sempervirens. Hundreds of thousands of acres of California coastline were covered with this type of forest before the 18th century. Large areas have been felled for timber, and even more have succumbed to fire and not been repopulated by native varieties. While we're thinking about the size of these trees and the communities that they form, and while we're here in the park, I want you to be on the lookout for certain types of predator or prey interactions. If you see different types of animals, whether they be living in the soil or flying around, or walking around for that matter, we'll be doing some internet research ahead of time to find out things that we might not necessarily see while we're here at the park. The sequoia community here is a stable environment, and barring any type of fire, these will be the climax community for the area. An additional term I want you to remember for the end of the term. Let's head to the next spot. As a bit of a side note, I'd like to point out this bit of human intervention in the park, where Friends of Salsal Creek, a non-profit group in the area, is trying to reestablish this area with native plants. And if you look at each individual, these are all native forbs. Let's head to the next spot. During these next few weeks, I'll also be introducing you to 3 mathematical models. Now, I know in my own experience in high school and transitioning into university, I hadn't been exposed to how math and science got together. Math class did math class and science class did science class, and I didn't really understand too terribly well, especially when I went into labs in my freshman and sophomore year, my first time I went through a bachelor's degree. On the first page here we have the exponential growth model, both the graph and 3 explanations of it that are in algebraic terms. Exponential growth indicates a population that increases in size without ever reaching equilibrium with its environment. It keeps growing and growing and growing and growing. I can only think of one population on Earth that does that: humans. We'll be exploring various modes of exponential growth and showing why this isn't necessarily sustainable and how this doesn't necessarily apply to the natural world. This next one we have here is the logistic growth model, or the logistic curve. You'll notice the shape through the middle here. It's sigmoid, something I'd like you to remember for your final exam for this class. This is more appropriately how things react in the environment, ecologically speaking. They start out in small numbers and populations, increase rapidly, and then level off at some point. That some point is called equilibrium. Equilibrium isn't necessarily shaped like a flat line up here. It might be more like a sine wave, something else we'll be talking about in the classroom. This third one we have here is the logarithmic model. Population will increase rapidly and then level off rapidly. We'll be giving more examples of these 3 types of nonlinear equations in class, and I'll be doing a lot more explaining, but I want this to be the first time you see it. I don't want it to be intimidating, so we'll be talking about this a lot, and there'll be a lot of demystification going on. Thanks, and I'll see you in the classroom. Hi, my name's Shawn and I'll be leading you through the next couple of weeks through a unit discussing succession, ecology, producers and consumers. I've completely lost my fucking train of thought.
2, 1.
Hi, my name's Shawn. God damn it. I gotta get fucking through this. I can't. Here where the video ends, and just want to be sure you understand that we'll be covering a lot of terms and ideas that you haven't heard of before, especially math as it relates to biology. I don't want you to be too scared. I don't want you to I also don't want you to, damn it. In an old growth area of the park that's dominated by Sequoia sempervirens, or coast redwood. Very large trees, evergreen. The whole coast of California used to be covered in these. This whole area now on the eastern side, or I'm sorry, the western side of the park is sporadically covered with these. And as you can see, I'm not really sure where I'm going with this right now.
2, 1.
Hi, my name's Shawn. God damn it. I gotta get fucking through this. I can't.
Dad!
You good?
Would you give me the, just the last part of that, follow me to the last area?
Yeah. Follow me to the west area.
Follow me to the next
No.
area. Okay. Okay.
Follow me to the next area.
We're rolling.
Coming to you from Joaquin Miller Park. We're standing here at the edge of a field. This field burned approximately 150 years ago. It used to have all of these trees standing in it. This was the break line right here. In this field now is dominated by grasses, forbs, and a little bit of shrubs. And on the very edges you'll find some seedlings if you look really hard of this particular tree. Behind me to my left you can see the San Francisco Bay Area. Well, this is an ecologically interesting area. What you can't tell right now is that there's a lot of wildlife around here. Most of it's down for the day because it got pretty hot here earlier, but there's a large variety of rodents and birds available in the area for you to look at. And you can't tell right now for sure because they're usually active earlier. Check out this monster. This is a little guy in the coast redwood community. Hundreds of thousands of acres of California coast were covered with these trees before white man settled the area. While Check out this little guy. This is a small example of the coast redwood, or God damn it. We're standing directly across a man-made road from the field we were just talking about. Right behind me is invasive non-native eucalyptus called Eucalyptus globulus. It was imported in the early days of the gold rush in the bags of seeds of migrant workers. It has since spread all over the Bay Area, and as you can see from the constituency below here, it doesn't let other things grow so readily. It's called allelopathy. It produces a chemical that's moderately toxic to other plants, especially other woody plants. So below here you'll see a lot of weeds, especially Canadian thistle. Now what does this say about biodiversity in terms of this area, directly below the eucalyptus, or the effect the eucalyptus itself has upon biodiversity in the area? Let's go on to our next spot.